open your books to page 244. We are going to cover some of the questions in lesson 16.2 that we didn't talk about because this is going to help you in your practice and your quiz. So remember we were talking about Axel and Anisa that were trying a new plan in which they could upload no more than 350 terabytes per month. In 16.1 they started out with 250 and they increased it to 350. So on the grids below, they're going to remind us that X stands for Axel and Y stands for Anisa. Question A, suppose Anisa, who's Y, does not upload anything for a month. Write an inequality that represents the amount of data that Axel, who's X, can upload during that month, and then we're going to graph this on the inequality. We're going to graph the inequality on the graph provided for us. So we did this a little bit in 16.1 as well. So if Anisa uses nothing, Axel can use all 350. And could we be exactly equal to 350? Yes. Can we be greater than 350? No. So X has to be less than or equal to 350. So in order to graph this, remember in activity 15 when we were drawing vertical lines at X equals a number? So on our X-axis, we're going to go over to 350, and we are going to draw a vertical line because we want it to touch the X-axis but not the Y. And I knew that this was going to be a solid line because of my inequality symbol. Because it has the or equal to line underneath, we draw a solid line. Now let's think about shading. We want to shade all X values less than or equal to 350. So is 60 less than? Is 180 less than? What about 0? What about 280? Yes, so we are shading everything to the left of our line. So shade the entire graph to the left except for that one little strip or column of boxes. So all of these numbers are possibilities or answers or amount of data that Axel can upload because Anisa is using nothing. And then make sure that I can still see that your line is solid, especially if I'm grading your homework. So if you wanted to choose a test point to plug in, you could choose 0. Is 0 less than or equal to 350? Yes, that's a true statement. So I shaded towards 0. Or ask yourself, which X values on your X-axis here are less than 350? Whatever way you want to think about it. So let's switch gears here and say that Axel, which is X, does not upload anything. We're going to write an inequality for Anisa. So Y, the total amount would be 350. We could be less than that or exactly equal to that. So this time, we are going to graph on our Y-axis, because there's a Y here, at 350. And when we have a Y, it's a horizontal, and maybe we need to make a note of that. It's a horizontal line because I want to touch my Y-axis, but not the X. So we are parallel to the X. And because of my sign, my inequality sign, or my inequality symbol, my line is solid. And let's think about graphing this. I want all y values less than or equal to 350. Anisa can upload anything less than or equal to 350. So, is 90 less than 350? Is 230? Is 0? Yes. So we are going to shade everything below this line. So almost the entire graph. And again, if you wanted to, you could plug in 0. And this was a true statement, so we're shading to include 0. Question 4 on page 245. This graph represents another plan that Axel and Anisa considered. The x-axis represents the number of terabytes of data from photos that could be uploaded each month. So we're no longer having our x and y stand for the people. Okay, x stands for photos, and that's why it's labeled on our x-axis. And the y-axis represents the number of terabytes of data from text files. Okay, text files. So let's identify our x and y intercepts because that's what question A wants. So my x-intercept is 180. And what does that represent? That represents the maximum number or the highest amount of terabytes of photos that could be uploaded in a month if and only if 0 text files are uploaded. So 150 terabytes of photos, 0 terabytes of text files. So my y-intercept on my y-axis up here, where do we start? It's at 0, 360. So this 0 means 0 terabytes of photos are being uploaded, and 360 is the maximum number of text files that could be uploaded. Okay, so those are my x and y intercepts. And then question B says, determine the equation. Well, the easiest way to write an equation from a graph is y equals mx plus b. M is our slope. B is our y-intercept. Oh, we already know what our y-intercept is. So y equals slope x plus b, which is 360, my starting point on my y-axis, my y-intercept. But let's find what our rate of change is or what our slope is. Rise over run, our m value. So I'm going to use this 360 because it's already up there. And here's another point. Here's another point. Let's count our rise over run. Let's fill in our scale first. So 0 something 60. Half of 60 is 30. 0 something 60. Half of 60 is 30. So each box or each line, our scale here is 30. So I'm going down. So I know that my slope, my rise over run, my m is going to be a negative. 30, 60. 2 boxes is 60. From 360 down to 300. We went down 60. And then from 0 to 30, one box is 30. Does that reduce or simplify? Ooh, it does. It reduces to -2. Right? Down 2 over 1. And it works because my scale is the same on the x and y axis. So my slope here would be -2. So y equals -2x plus 30. But question C, we know that we can't write an equation because an equation has no shading. Okay, an inequality has shading. Okay, so I'm going to keep my y and -2x plus 360. And what we kind of need to figure out is what our inequality symbol is going to be here. So the first thing I look at is my black boundary line solid or is it dotted? In this case, it's solid. So because it's a solid line, I know I have two options for my inequality symbol. It's either less than or equal to, greater than or equal to. Because of this equal to, it gives us a solid line. So I know for this question, I'm going to have or equal to, but how do we figure out if we're less than or greater than? Okay, we're shading towards 0, 0, right? So we could use that test point of 0, 0 and see if it's true or false. Okay, well, what do you think? If it was true, we would shade towards 0, 0. If it was false, we would shade away from 0, 0. So we need a true statement here. So let's think about which or what inequality is going to give us a true statement. We know it has to be true because we shaded towards 0, 0 below our boundary line. So if I put a 0 in for x and a 0 in for y, it looks like this. And anything times 0 is just 0. So I get 0 and 360s because those cancel out. And I'm trying to figure out what sign goes in my box here to make this a true statement. So is 0 greater than 360? No, that would be false. So my sign here has to be less than. So y is less than or equal to -2x plus 360. The check your understanding box on page 256. Here's question 5 in the check your understanding box. You can just draw a rough sketch in the My Notes section of your book, or you can use some graph paper. You only have to go from like -4 to +4. So if I think about graphing x equals 3, that is a vertical line at 3. So on our x-axis, we're going to go over to 3. And I'm going to plot that point. And I want to go through my x-axis. So I know that this line has to be vertical. And is this solid or dotted? Or dashed? It's dotted because I do not have an or equal to line underneath. Okay, and then look at visually, hopefully this helps you. Look at this x-axis right here as a number line. I'm not drawing in a line. I'm just highlighting it to point it out to you. So look at this x-axis as a number line. Our inequality says all x values less than -3. So is 10 less than -3? No. Is 7? No. So I'm not going to shade to the right. I am going to shade towards the left because 0, oh, I screwed this up. I graphed at a +3 instead of a -3. So, good thing I caught my mistake before I confused you entirely. Hopefully you caught it before I did. There's a -3 here. So, for shading purposes, it still stands the same. Is 10 less than -3? No. Okay. Is 6 less than -3? No. Is 0 less than -3? 0 less than -3? Nope, still false. What about -4, -5, -7, -10? Are those less than -3? Yes. So what we're going to do here is we are going to shade to the left. Less than -3. Good thing I caught that mistake. Less than -3, we go to the left, towards -4, -10, -28, etc. Okay, question 6 is y is greater than 2. So I need to go and draw a horizontal line for this one and think about it being at y equals 2. Okay, so here's 2 on my y-axis. Is this line going to be solid or dotted? This is going to be dotted. Because of my sign, I do not have an or equal to line. And this is saying I need all y values greater than that. So vertically up and down, if I'm looking, okay, think about, are these numbers greater than 2? Or are these y values greater than 2? Or if you would like, you can plug in a 0. Is 0 greater than 2? False. But 4 is, and 5, and 7, and 8, etc. So we are going to shade all y values greater than 2, which means above our line. So we're shading everything up here. All these y values are greater than 2. But I'm not shading below because -5 is not greater than 2. -9 is not greater than 2. 1 is not greater than 2.